Welcome to the Will the Orange Guy Computer Studies Code project on GitHub. This is an archive of code for most of the day's AP Computer Studies projects that I did in my AP Computers class. As you can see, there's links to sponsor the project here, as well as the fact that the project is written in Python and HTML. So those are the two kind of projects that we did in class, both Python and HTML projects. As you can see, there's some images here. This is a logo I made using their text to visual tool to represent the CodeHS logo, which is the project we use. Also some ghosts that I built in Python and some square boxes using a program called Carol, which could draw on boxes. As well, I also drew a story about my computer failing to work and getting a new one. The key features of this are that there's Python GUI projects, Python Carol projects, Python scripts, and HTML and CSS websites. You can download the source code to run this project on your local computer, or for the projects that require CodeHS, you can access the CodeHS website here to run the projects there. It's built with GitHub, the Python Software Foundation, and PyInstaller, and is licensed under the GNU General Public License, which you can access here in the repository code. And scroll back up the page here, and we can see each of the individual program folders. And so we have for my AP performance task, which was a POS system that replaces this POS system with a Dairy Queen. It uses tkinter, creates a function for each button, and applies certain coupons. Lists are storing the ingredients for each item, and there's lots of repetition in the code, which makes it easy to finish in the amount of time that we had. So you can access the main file for the code here by going pos_GUI. And scrolling down, there's some sources for stuff from Stack Overflow that I used. Imports the time, the tkinter widgets, creates a window, and has lists for the order items, order prices, and the discounts, as well as the total price. Now using this function here, what it does is it will check and add up all of the items in your order, as well as check to see if you have cheeseburgers or chicken wraps, and do a 2 for $5 meal deal. Here you can see that it goes through the items in the list and adds them to the window. Then it will show the order total in the Tinker message box. Has functions for grill items, blizzard items, chill items, drinks, beverages, and cakes, as well as the ability to delete an item or create an open food or an open discount. Then it'll ask about the open food, what value you want to add, ask about the discount, what discount you want to add, and then there's also a main function here, which has the title POS_GUI, as well as version numbers, and then has buttons for the grill, showing a bacon cheeseburger, an ultimate burger, a cheeseburger, a hamburger, a crispy chicken, a chicken wrap, as well as mini, small, medium, and large blizzards, peanut butter parfaits, banana splits, as well as small, medium, large pops, fruit smoothie, an orange Julius, a banana, and then some blizzard cakes, some regular cakes, and some dilly bars and sandwiches. Then it has the order buttons as well as the total, and it positions all of those things on the page in a grid. Finally, the window is built by the main and the main loop command. We can head back up to the top of this long piece of code here, back to the main repository to see our CSS extra challenges. So for this, I had to create a table of my favorite things and use some CSS to stylize that table. So you can see here is the table, and here that I've highlighted is the CSS stylizing it. Can head to the digital information challenges here, where I created a project to brute force Python pins. So it asks what your pin is, checks how long your pin is, goes through the number of zeros from 0 to 9, and iterates through those to guess the pin. When the pin that it guesses matches the user password that you've inputted, it says how long it took, as well as using the time function to tell exactly how long it took and how many seconds. Then it also uses this guess to passcode function, which does basically the similar thing. It guesses a 4-digit passcode by running through the 4-digit numbers and then prints out the thing. This is basically the same as the previous one, except this one only will do a 4-digit passcode by guessing random numbers itself and then comparing it against that. So instead of you inputting your pin, it guesses pins for itself and guesses them against itself. Then there's also this function here that does text to binary, so it converts text in letters and takes decimals into binary and then prints the text that was originally in ASCII characters to binary. I can head over to the HTML extra challenges First, I was challenged with making a collage. So I took some images from Wikimedia and added those in a collage, as well as their source and exactly what they were. I also created a page of national parks, which can be found here using images from Wikimedia as well. A table of favorites, which we saw earlier in the CSS, but this is just a table of favorites, just a blank table, and there's no actual code being added, or CSS styling being added to it, I should say. And there's also vacation guides, so places I would have liked to travel, links to where you would find these world travel guides, and links for when you should visit them and how long I would like to visit them for. Heading back to the main page here, we can see the Carol challenges. So this was the built-in tool in CodeHS, which allowed you to move this dog around the screen. Each one of these files also has a debug file, which has each of the movements coded as a original Python code. So that way you can try it on the Python interpreter without having the Carol module installed. For now, I'll just go through the Python files. So what it would do is it was going to draw a checkerboard, and it would paint some red, paint some black, and it also had a function to go home. So through the range and through the individual image, it would go red, black, red, black, red, black, all the way to create a checkerboard pattern. There's also the double tennis balls, which would move the tennis balls and put double the amount of balls that were originally there. This is built up with two functions using, of course, already implied take ball, turn around, move, put ball, turn around, and move functions. Those were part of the Carol tool, so I did not need to code those myself. Here it fills the whole entire grid with a ball by running through this range 80 times. Then we move on to Racing Carol, which had Carol run around the racetrack 8 times, putting a ball on each corner. There's also the pixel art with Santa on it, which painted Santa's face in pixel art using the Carol color command. So it has the move to outline, go home functions, turn left, turn right, move up, move down, and painted the outline, which was a lot of just coding it and making it work. As well, it painted the face and painted Santa's hat, and then did each of those functions individually, and they were called down here at the bottom. Going back up to the Carol challenges, there's also Super Cleanup Carol, which would go through the thing and move throughout the entire world, cleaning up all the balls. So it goes through the row. If there's a ball present, it'll take the ball and move, otherwise it will just move. If the front is blocked, it turns around and does the row cleanup again, and just moves back and forth, taking them up. And just in case there's never a ball that isn't there, or there's something that's been missed by the program, if there's a ball there, it'll take it. Now we can go to Tower Builder, which would build a stack of balls on every other column. So it builds a stack, moves, builds a stack, moves, builds a stack, so on and so forth. And while the front is clear, it is going to do that function. Now heading back to the main page here, we can see our Python challenges. So there is a better password prompt than the one I personally had before. So you enter a new password, it converts it to an MD5 hash, then turns it to a hex and checks to see if the password you have put in matches the password that was originally there. There's also the option using their color module to draw something. So it draws shapes such as rectangles, circles, rectangles, and what it did was it drew the CodeHS logo, which we saw on the original first page of the README. Also the ghost, which we also saw on the original first page of the README. This would draw a ghost and drew a whole bunch of ghosts in specific colors. There's a guessing game, which guesses the numbers, whether they're high or low. So I'm thinking of a random number between 1 and 100. You're supposed to guess the number that it's thinking. You would put in the number, and it would guess either it's too high, too low, so on and so forth. How many names function. So what this does, it takes a list of names, asks how many names you have, and then prints them out as first, middle, and last names. There's the librarian function, which asks for a number of full names and returns the last names in order. So what it'll do is it'll take the full name of the author and return it in a list with the last name first, and so on and so forth. These ones here make Carol move throughout the world. This is actually not the function that I have created. This is a function that was behind the Carol project that we used. Then we can move to the owls program here, which takes this sample text down here at the bottom, this nice long thing, and talks about which talks about owls. The text talks about owls, and it counts throughout the text how many times the word owls is used and where they were and what indices they were on. Then there's also the shape area calculator. Now this takes in what kind of shape you want, and such as a square, rectangle, triangle, circle, ellipse, trapezoid, parallelogram, rhombus, kite, pentagon, hexagon, octagon, annulus, ring, and takes those in and calculates their length. So for example, the square here just goes length times length, rectangle goes length times width, the triangle goes the length times height divided by 2, circle is pi times the radius times 2, and to do the ellipse, it's the height divided by 2 times the width divided by 2 times pi. Trapezoid is the length plus base times height divided by 2. And for parallelograms and rhombus, they're really just squares on the side, so it's a base times height. Kite width times height divided by 2. Pentagon length times 2 times the square root of 25 plus 10 times mass square root of 5 divided by 4. That's some very complicated mathematics in there. I feel like a lot of these functions were probably taken from the internet. And there's also the hexagon area, 3 divided by 2 times math times the square root of 3 times length times 2. And then there is also the octagon and the annulus area. Now, each of these is printed out to the format with the area of your shape is whatever with centimeters behind it, and then a squared, which is as a superscript in the actual code. There was also a help option, which would show a list of all the available shapes, as can be seen here. Now there's a thermometer temperature check, which would take the temperature, what your current body temperature is, and if it was in Fahrenheit, would convert it to Celsius. Now it would create a stoplight, a red letter green stoplight, and a blue, green, orange, and red. So similar to a stoplight, but with blue for hypothermia. And would show if you had hypothermia, seek medical help. If you had a normal temperature, it would be green, say normal, good to go. If you had a fever, it would be orange, say stay home and recuperate. If you had hyperprexia, which would be red, you should seek medical help. Now you can see the temperatures here because it would take all the temperatures from Fahrenheit and convert them to Celsius. If you were less than 35 degrees, you had hypothermia. If you were between 35 and 37, you were normal. 37.5 and 40, you had a fever, and anything greater than 40, you had hyperprexia. And finally, the word ladder. So what this would do is, this is all coded out, or commented out, sorry, because CodeHS doesn't like it. But basically what it would do is it would take the number, or take a word, and then you had to change each letter in order to make it do a different word. So heading back now to the main repository, we can go to our Python extra challenges, and there's a random number generator, which would generate the random number and then have to play a guessing game, basically almost exactly the same as the program that we showed before that was a guessing game. And then rock, paper, scissors, which built off the guessing game, but it also tracked your wins and losses. So it had the options of rock, paper, or scissors. The program would print rock, paper, scissors, shoot, and then you'd say what you did, and then it would convert rock versus paper, rock versus scissors, paper versus rock, paper versus scissors, scissors versus rock, scissors versus paper, and then see whether you win or lost. Yes, so that is all the code in that project. And hopefully, if you are taking a computer studies class or doing work on CodeHS and you need some help looking at projects or what to do if you're unsure, you can access this repository and you can see exactly how to do each of those projects. Okay, so I've opened up the computer studies code repository here on my local computer, so we can go through and see all the Python and HTML projects as they actually work. So we'll start off with the POS GUI, which is the AP performance task. So I'm going to open that in terminal, and then I'll run the Python POS underscore GUI.py command to launch it. Opens this nice window for us here. It says POS GUI on the top, has all the individually colored buttons for each category of item. So we have, as alluded to before, bacon cheeseburger, ultimate burger, cheeseburger, hamburger, crispy chicken, chicken wrap, mini blizzard, small blizzard, medium blizzard, large blizzard, peanut butter parfait, banana split, a small drink, a medium drink, a large drink, a fruit smoothie, orange Julius, and a banana. And then our novelties, so 8-inch blizzard cake, 10-inch blizzard cake, 8-inch normal cake, 10-inch normal cake, 12-pack dilly bars, 12-pack sandwiches. Then over on the side here we have the time, an order item list, as well as the total value, and then extra buttons for deleting the last, editing the last, adding an open price or an open discount, and taking our final payment. So let's start by adding a bacon cheeseburger, and then we're going to click on the cheeseburger button. It's going to ask us for the coupon, and we say yes, we want the coupon. So now we have 2 cheeseburgers. Now if you look down below, you'll see that it is showing us our values here. So we have a bacon cheeseburger and a cheeseburger and another cheeseburger in our list, as this list is here. Here's all our price values, and here's our total value. Now we want a large blizzard for dessert, medium drink, and 2 8-inch cakes to take home. You can see all of that is reflected down at the bottom here as well. Now we actually want 1 8-inch cake, so we're going to delete that last. This total comes to $49.50. So we're saying we want to donate 50 cents, so 0.5. Accept. We've donated 50 cents, now it's $50. But actually we're an employee, so we're going to take 50% off. Accept. Oh, now it's $25 exactly. So we're going to take our payment by going here, processing to our payment machine, and it's going to say that our order total was $25. Go OK, and the program exits. Now we can move on to our CSS extra challenges by exiting this folder, and we can open the favorite things table, which shows a stylized table of favorite things. So here you can see our daily favorites table, got all the headings on top bolded using CSS and colored, and then the rows are colored each are a different color after every other row, just like that. Moving back to the main repository here, we can move on to our digital information challenges. So we'll open the first one here, the brute force, in our text, or sorry, in our terminal. So it's going to start off by asking us what is our PIN. So let's say our PIN is 1234, and the computer is going to guess all numbers going all the way down to 1234. Found our password, and it took 0.33 seconds. Now we'll prove this we'll prove how this is not always true, because if I go 9999, it'll take much longer for it to guess through, only because it's just guessing through numbers in a normal order. And moving on to our next thing, we can see the guess the passcode option here. So we'll go Python, yes, the passcode. Fine. And so now what it's doing is it's randomly generating a passcode and guessing it on its own. So it's took 0.61 seconds. Let's have it guess another passcode. This should be a different one. Now it's 2462, took 0.53. Guess another one, 1.64, and we'll guess one more. Oh, look at that, 9977. That's way further in, and it took a whole 2.6 seconds for that one. Now we can move on to our text to binary converter. So it's going to input a string, let's say hello world, and it's going to input that to binary. Let's take another string. Python is awesome. We're going to put those all in the capitals, and it's a much longer string, only because it's a longer thing. Now, if we want to just take its temperature, if we just want to do a specific character, let's say we want to know what an A is in binary. Let's go A, and that's what an A is. You can also try numbers, so 1 million, I have no idea how many zeros that is, but whatever size number that is, and it looks like that. Alright, so we can exit the terminal there and head back to our HTML extra challenges. So we'll start off with the make a collage challenge.
So the Make a Collage challenge has loaded, and basically it's a whole bunch of images from Wikimedia Commons in a little row on a nice page here, including their source links. Now that we're back into the repository, we can move on to the National Parks Challenge. So here there are a whole bunch of images from specific national parks, all coming from Wikipedia. And as you can see, if I hover over the image, it will show a link to that specific Arches page. Oh, sorry, this is Arches National Park, but a specific link to the specific Wikipedia page. They've all been stylized, so that way they're all the exact same size. So we'll test those links, clicking on this here, and we go to Arches National Park, showing a very similar picture. And we can scroll down and learn more about Arches National Park. And I think actually right here is a picture that I used in the project. So now that we're back in the HTML Extra Challenges folder in the repository, we can try our table of favorites. So this is our table of favorites loaded in Edge here. It's very similar to the one we had before, but it now has just no styling and no coloring. Now back in the main repository here, we're in the HTML Extra Challenges folder again, and we move on to our vacation guides. So now that the vacation guides file has loaded into Edge, this is just Dream Vacation Destinations, a very basic page with some links, as well as 5 different countries that I'd like to visit: New York, Holland, Germany, Brazil, and Japan. Let's say, for example, we want to go to New York. We can click on this link here, and it should send us to the page. There we go. We are here, and we see our New York City travel guide. Oh, we need to disable our ad blocker. And we can see here there's accommodation, featured hotels, and more about the website that I'm using, so the World Travel Guide. Now we're back in the repository, so we can move back to our Carol challenges. So for each of these, this would have to be used with CodeHS, but we can see our debug files here, which will allow us to do the project by printing out the commands to the terminal instead of what would actually be shown on the CodeHS screen. So we're going to start off by going Python checkerboard underscore Carol dash debug .py, and it'll run. So each of the commands is running here. So we have, as you can see, we gotta scroll all the way up, but it says paint the square black, Carol moves, paint the square red, and then it's checking all of these commands to go all the way through. Let's try the double tennis balls one. Tennis has 2 ends. And Carol moved. Are there balls present? Are there no ball present? Carol turn left. Carol turn left. Just like that. Now you can try the fill the grid. And we can see all of the debug output for filling the grid. Let's go into all of those. Okay, now we'll move on to the racing Carol. So, just like this, checking to see if the front is clear, putting down a ball, turning left, so on and so forth. Looks very repetitive for this one. Now we can move on to our pixel art. So this would have painted pixel art by making squares a specific color with Carol. There we go. So we can see all of these commands in order to paint the thing. Carol moved many times here, turned left, moved all around the grid, and then painted the page. Moving on to our super cleanup Carol. And it checks to see if there's balls present. Now, this would normally work if there was balls actually present, but obviously I have not programmed in balls in this situation, so there's no way for it to tell. And we move on to our last one of this folder, our tower builder. There we go. Carol put down a ball, Carol moved, Carol put down a ball, Carol moved, and so on and so forth. Now we can close our terminal here, move on to our computer science code, and we move on to our Python challenges. So we'll start off with our first one here, opening it in terminal. We have our better password prompt. So we're going to put in our password is password1. Now this uses the built-in function to hide passwords, so you will not be able to see the password. And now we have to put it in again. Oh, look at that, I guessed it right away. Now let's say we want to try that again. I'm going to put in a different one. It has to be 1234. New password 9999. Oh, that did not match. Hello world. Let's try that. Oh, that didn't match either. 1234. Oh, it matched. Good job. We can't test out the draw something one or the ghost one, as those were also built specifically for CodeHS. We can try the guessing game though. So it's thinking of a number between 1 and 100. So we're going to guess 88. Too high. Okay, let's guess 34. Too low. 67. Too low. 78. Too high. Let's see what's in between there. 65. Too low. Oh, I should have known it was 67. Why did I guess that? 70. Too low. Okay, 72. Too high, so that means it must be 71. Good job. We got it on number 71, and you can see here it'll say guess number 8, so we know how many guesses we've taken. Let's play that game again, and we'll learn a little trick. So if it's between 1 and 100, we can guess 50 to start, because it's right in the middle. We know that's too low. So now let's split it again. 75, still too low, so that means between 75 and 100. Split it again, 87. Too low. So now we know it's between 87 and 100. So split it again, 93. Too high. So now we know it's between 87 and 93. So we're going to go right in the middle, 90. Too low, 92. Too high, 91. There we go. So that took 7 guesses, but that is a faster method. We'll see if we can try to make it faster this time. So 50, too high, 25, too low. So that means it's between 25 and 50, so we'll go 38, too high. So it's between 25 and 38. There's 7, or not 7, there's 13 digits between there. So we'll go 30, too low. So we're going to go 34, too high, 33. There we go, 33. We got that in 6 guesses. Okay, moving on to the next one. We can do our how many names. How many names do you have? I have 3 names. Bob, Smith, Jr. My first name is Bob, my middle name is Smith, and my last name is Jr. So it's taking our first and last names as strings and then putting our middle names as lists, just in case maybe you have more than one middle name. Okay, now we are going to check our library and program. The full name of author 1. Let's do Gordon Corman and J.K. Rowling. And what's another common author? James Peterson. No idea if I'm spelling that right. Okay, I don't have any more. So you go like that. Oh, I believe there is a error in this program. I'm not sure. I think I have to go -1. Oh, so I actually have no idea how this program works. So I wrote this in AP Computer Studies, and I guess I have a fence post problem that I forgot to figure out. Okay, now we can move on to the owls program. So we go python owls.py. And so we put in some text. I love owls. My mom loves owls, but my dad and my dog hate owls. Oh, there's 3 words that contained owl. The Euclid is 2, 6, and 14. And remembering that the computer starts counting at 0, so the third word is actually the second in this list. Okay, now we're going to move on to our shape area calculator. So it's going to ask us what kind of shape. Let's say we want to do a triangle. Base length 2, height 30, and our thing is 30 centimeters. Well, because of course our base length is 2, so it's times 60 and dividing by 2. If we go help, we can see all the different shapes. Let's say we want to do a kite. Our height is 33. Our width, 45. 142.5 centimeters. Let's try a ring. The inside circle radius, so we're going to have our inside circle radius in centimeters of, let's say, 1.5. And our outside radius is going to be 2.0. So the analysis of our ring is 5.49. Look at all the digits is rounded to there. And we can try quit to leave. All the other programs require the CodeHS module to run, so we're not going to be able to run those here. Now, one important thing is I will also have a CodeHS tutorial on all of the things in CodeHS, all the programs that we did coming up later on. So if you want to see that, make sure you get subscribed so that way you can see those videos coming later on. Now moving on to our final folder, we have the Python extra challenges. So these are much similar to some of the things we saw earlier, but we're going to start off with our random number generator. So this is just basically the guessing game as before, but it's generating random numbers, which you already knew. However, this time you only have 10 guesses. So we'll show what happens when you don't do the 10 guesses, and then we'll apply the trick we learned before in order to make sure that we actually do get our 10 guesses. So we're going to go 33. Too low. I'm going to guess 40. Still too low. 45. Still too low. 56. Still too low. 78. Oh, that's too high. Okay. We're going to try 60. Too low. 62. Too low. 77. Too high. Let's go 65. Still too low. Okay, now we're on our 10th guess, our last time. So we're going to go 68. Too low. Sorry, you did not guess in time. The number was 74. This is what happens when we don't guess in time. Now let's try this again with our trick. 50. Too low. 75. Too high. So it's between 50 and 75. So we're going to split that in half. 62. Too high. Okay, between 50 and 62. Split that in half. That's 12. So it's going to be 56. Too low. Between 56 and 62. So that's 6 in between there. So that means we're going to try 59. In the middle, look at that. I got 5 guesses. Perfect. Okay, let's try our rock, paper, scissors game this time. So I was going to play rock, paper, scissors. It says rock, paper, scissors, shoot. What did I shoot? Let's say I did rock. So I tied. Okay, this time I did paper. I tied again. Wow. This time I did scissors. Oh, I won. Wow, 1 win, 1 loss. Look, it scores that for me. Okay, we're going to try rock again. I lost this time. Now I got 1 win, 1 loss. Fire, scissors. I won. Okay, let's try our paper. I won again. Wow, 3 wins, 1 loss. Okay, we're going to try backwards now. Scissors. Oh, I lost. Okay, paper. I lost. Hopefully we can end off on a winning one. And wow, I lost the end. I have to keep playing. Oh, I see. So I spelled it wrong, so this is what I tied. Oh, I tied again. Rock. Oh, I won. There we go. Okay, so 4 wins, 4 losses. Good. Exactly perfect. That is a good way to end off. So I'm going to close it off. So there you go. And there's all the projects from my computer studies code backup. If there's anything else that you would like to see, especially those CodeHS ones, then make sure you stay tuned because I will have videos on every single CodeHS assignment so that way you can follow along with those if you're in the class or if you just want to learn more about coding. Thanks.